In the previous video, we introduced continuous random variables, and today we're going to start looking at typical exam questions, and the most frequent of those involve probability density functions and testing knowledge that basically is that the integral between infinity and minus infinity of f of x equals 1. That's the first piece of knowledge that they test, and the second one is that f of x is always greater than or equal to 0, f of x being the probability density function. These are the two absolute must-know things, and they test them all the time. So let's have a look at question number 1. The first question we're going to do is a very standard question. The second one actually has a little twist to it. So this first question, let's have a look. Okay, so we have a continuous random variable has probability density function described by f of x equals, okay, so let's just go through this quickly. So that means k times x, and we have to find what k is. It's k times x if x is between 0 and 4, and if x is not between 0 and 4, then f of x is 0. So we can draw a nice little chart of this. Let's just draw a graph here. So we have f of x here, and we have x here, and here's the point 0, and here is the point 4, and let's just draw a line up there. Basically kx is this, so this here is kx, so this point here, obviously because x is 4, that is the point 4k. All of the values of fx here and greater than 4 are equal to 0, so we are only interested in this bit here between 0 and 4. Now basically what they need us to do to find k, whenever we have a question like this, what we need to do is we need to find the area under the curve, and the area under the curve we would normally find by integrating our probability density function and then equating it to 1. But in this particular question we're going to do it two methods. The first method is actually a very simple method by literally just finding the area of the triangle. This is the area under the curve, the probability density function, and so we know that that area equals 1. Now given that we know this is equal to 4, and we know this is equal to 4k, because when x equals 4, f of x equals 4k, we know therefore that the area of our triangle is equal to 4k times 4 over 2, just by the definition of an area of a triangle, and we know that that equals 1 because the area underneath the probability density function, or the integral between infinity and minus infinity, must equal 1, and therefore we have that k is equal to 2/16, which is 1/8. So in actual fact we can answer this question here just by looking at the area of the triangle. But anyway, as this is a how-to, let's also do it by the integration route. So basically, let's imagine it wasn't a triangle. So we would have to go, okay, well, the integral between infinity and minus infinity, by definition, of any probability density function, dx, sorry. Oops, I forgot my dx. My bad, equals 1. Now in this case we don't need to integrate between infinity and minus infinity, because anything less than 0 and anything greater than 4 we know is 0, so we only have to integrate here between 0 and 4 of fx dx, and we know that will equal 1. Well, fx is kx, so that means we have the integral between 0 and 4 of kx dx, which equals kx squared over 2 between 0 and 4, which equals 16k over 2 minus 0 over 2, which equals 8k, and we know that equals 1. This is the really important bit. We know that the integral of the probability density function equals 1. So therefore we have 8k equals 1. So therefore again, by the same logic as before, k equals 1/8. So we can see that whether or not we use the integral, or we notice that the area underneath the probability density function is something that we can calculate without integrating, we get the answer of k equals 1/8. Okay, now that's the first question. Let's have a look at the second question. Now the second question is a little bit tougher, and I'll explain why it's a bit tougher by drawing the graph. Now we don't need to draw the graph to answer this, but I'm going to draw the graph anyway. So let's just, we have a continuous random variable, probability density function, again f of x, between 0 and k, so this time k is here rather than here, but we still have to find k. There's only one unknown, find k. So between 0 and k, it is 5 minus 12x, otherwise it is equal to 0. So let's just draw this graph here. So basically here is the point 5, and here is the line 5 minus 12x. So this point here is the point 5/12. That's when the function is 0, and here is 0. And now, initially we think, well, hold on, k can be anywhere along here. But noting that we have already discussed this up here, where was it? I said it. A probability density function must always be greater than or equal to 0. And this is what they're testing in this second question here, is that the function here does go below 0. So clearly k cannot have a value which is greater than 5/12, because if k has a value greater than 5/12, then f of x is going to be less than 0, and it can't be. A probability density function cannot have a value less than 0. So we know that k must be less than 5/12 before we even start. Sorry, less than or equal to 5/12. Okay, but our integral doesn't know that. And before we answer the question, let's just have a quick look again. Let's redraw this, because this is important, and this is going to show you... let's draw it a little bit more like this. Okay, so here is our line here. Okay, so this here is our point 5/12, and this is 5 minus 12x. Okay, so basically, let's imagine if we have the point k here, then the area underneath here is going to equal 1. We know that by the definition of the probability density function. But let's have a look. Let's just put this in another colour here just for a second. This area here, if we had a k here, then this area here and this area here, whatever they are, let's call those areas A and, well, A, but it would be minus A. The integral of our probability density function is also going to give us this answer here for k, because the integral at this point for k is still going to be 1. It's going to be 1 here, which is basically that, but it's also going to be 1 here, because it's going to be that, which is 1, add that, which is whatever it is, take away that, which is congruent to that, and it's going to give 1. So we're going to get two answers, and we have to know that we have to discard the answer which is greater than 5/12, because that would give us a probability density function which is less than 1, which can't happen. Okay, so let's go on that. So basically, that was a little bit of an aside. It's so let's go. So we basically know that the integral between minus infinity and infinity of fx dx equals 1 by definition. So i.e., let's just go back to our question in case you've forgotten it. So between 0 and k, it's 5 minus 12x. So basically, the integral between 0 and k of 5 minus 12x dx, we know, is equal to 1. And outside of k, above k and below 0, it's the function is defined as 0 anyway, so we don't need to worry about that. Okay, so let's integrate that. So that equals 5x minus 6x squared between k and 0, which equals 5k minus 6k squared. Okay, and we know that that equals 1. So therefore, we now have a quadratic here, i.e. we have 6k squared minus 5k, add 1 equals 0. And here we're going to get, here's our two solutions. Let's just factorise that. 3k minus 1, 2k minus 1 equals 0, i.e. at first glance, k equals a third, or k equals a half. They are both solutions to this equation here, or this integral here. But we've already established that only one of them, well, in fact, only one of them obviously can be valid. It can't have two values. Half is greater than 5/12, and that's why we have to discard a half. And so our answer is k equals a third. And so you can see this one here, k equals a half, and this one here, k equals a third. We can only accept k equals a third as being our answer, even though it's giving us two answers. Okay, so basically k as a third is our answer. Now, just as a check, I'll tell you what, as a check, we've just about got enough space here. So f of a third is equal to 5 minus 12 over 3, which equals 1. That's just putting our function, our value of x. So basically, we can now draw what our function is. So basically, it starts at 5, and then this point here is 1, and this point here is a third, which is k. K equals a third. So basically, this is our function here. That's our probability density function here, is just that dark bit. And we can work out what the area underneath the curve is, just as a cross-check. We don't need to do this, but it's a good idea to just, now we're trying to learn how to do it. So the area of this clearly is equal to 1 times a third. And the area of this, well, that bit there is 4, and this bit is a third. So the area of the triangle is 4 times a third over 2, which equals 2/3, and then 2/3 add 1/3 equals 1. So our probability density function, the area underneath the curve, is indeed 1, which is as required. Okay, well, I hope you found this useful. If you have, please like the video and subscribe to the Gresty Academy YouTube channel, and look out for further videos on continuous random variables, which are all part of our Gresty Academy crash course in continuous random variables podcast. Thank you.